Hello, this is Chakravarti, and today we are going to discuss reaction of base with 3-bromo 1-phenyl but 1-one. Basically, the reaction is an elimination reaction. In the following slides, we explore whether the mechanism is E1 elimination unimolecular or E2 elimination bimolecular, or is it elimination via a conjugate base. In the given compound, if you look at carbon indicated with alpha, we show that there is an acidic hydrogen. Why is this hydrogen acidic? If you notice onto the right and the left side of this alpha, onto the left there is a keto group, onto the right there is a bromo. Both of them exhibit or exert minus I effect through their sigma bonds, which weaken carbon hydrogen bond at alpha position, making it acidic in nature. Now, since we have said that hydrogen is acidic in nature, ethoxide, a base, tends to attack at this acidic hydrogen, creating a carbanion-like situation. Carbanion formed at alpha position is stabilized due to presence of keto group at beta position, and also carbon bromine bond. Both these have a minus I effect which stabilizes this carbanion. Moreover, carbanion is in conjugation with C double bond O. That would imply that it is delocalized due to resonance. In the current slide, you see that carbanion is stabilized via resonance due to conjugation, and an enolate is formed, and there exists resonance between them. Now the enolate resonates back to the carbanion stage. In the earlier slide, you have seen carbanion resonating with the keto group. However, if it does not resonate and goes on to the right side, then it becomes a entering group, forcing the carbon bromine bond to leave. Due to the nature of entering group of the alpha carbon bromine bond leaves, and this leads to formation of an alkene. This kind of behavior is an elimination reaction, but the intermediate formed here is a carb anion, which is a conjugate base, and this conjugate base is stabilized by resonance at beta position. This kind of behavior can be treated to be elimination via conjugate base. This is the essential difference between E1 and E2. In E2 there is a transition state, and in E1 a carbocation is being formed. This reaction favors elimination via conjugate base because hydrogen shown at alpha carbon is exceedingly acidic in nature. Now that we have established that it is an E1CV reaction, what should be the stereochemistry of such kind of eliminations? The incoming group and outgoing group have to be anti to each other so that the transition states are energetically favorable. Now that has been shown here, indicated by a black lone pair pointing vertically up and bromine pointing vertically down. Now the configuration also shows methyl group and a phenyl keto group to be 180 degrees to each other, shown by pink spears. In this conformations, the groups face minimum amount of repulsions. Now the stable conformation is making sure that lone pair enters anti to the leaving group bromine and gives you an alkene, and you will notice that methyl group and the phenyl keto group are trans to each other, which by far is the most stable conformation. This is the final product of your E1CB reaction, where the keto group and the methyl group are anti to each other, and this gives it extra amount of stability. You will notice here in this particular compound that after formation E1CB reaction, the alkene is under extended conjugation, meaning that conjugation extends from ketone to benzene and from ketone also to alkene, shown by a green backup. Now ultimately we now conclude that this kind of elimination given by this molecule is an E1CB reaction. To put it in short, if hydrogen at beta position, that is next to 2 carbon bearing bromine, is exceedingly acidic, that is the correct condition for E1CB reaction to take place. Thank you.